Okay, so we're beginning experiment 21, which involves the synthesis and titration of a Grignard reagent. So, as part of our preparation of the Grignard reagent, we've weighed out some polished magnesium filings. We want to make sure they aren't too large or too small, and we want to be able to observe initiation and generation of our Grignard reagent via the evidence of bubbles forming on the magnesium surface. So we want to make sure the pieces are reasonably sized and such that we can observe the indicative bubbles, which are a sign that we've initiated the reaction and we're beginning to generate the Grignard reagent. So this is our first weight of the magnesium pieces used as part of our preparation of the Grignard reagent. So, as part of the preparation of our Grignard reagent, we've weighed out a small crystal of iodine. In addition, we have collected and added 100 microliters of anhydrous diethyl ether into our reaction vessel. So it is critical in the preparation of a Grignard reagent that your glassware is completely clean and dry. The presence of water will inhibit and quench any Grignard reagent generated, and trace impurities can interfere with the initiation process. So, as such, we have cleaned and then dried all of our glassware in the oven for approximately 30 minutes to an hour, and then we allowed all of our glassware to cool in the desiccator. We've also prepared a calcium chloride drying tube to help ensure a dry atmosphere as we initiate and begin to generate our Grignard reagent. So, in the next steps, we are going to be adding an additional aliquot of anhydrous diethyl ether. Then we are going to heat this mixture and look for the characteristic generation of the purple iodine vapors. And then finally, we are going to add our alkyl halide slowly and generate our Grignard. So we'll resume once we begin our initiation process and we start to observe, well, first and foremost, we have to make sure that we're observing the characteristic iodine vapors, which is a sign that our magnesium and iodine are set up and prepped and ready to go for the addition of our alkyl halide. Okay, so at this stage, we are beginning to heat our reaction mixture. We haven't yet added our alkyl halide. We're just heating the magnesium and iodine, and we're looking for generation of the characteristic iodine vapors. That's a sign that our magnesium and iodine have been activated and prepared for subsequent addition of our alkyl halide and for formation of our Grignard reagent. So we're going to do some close-up shots of the inside of the reaction flask, and hopefully we'll be able to observe the characteristic purple color associated with the iodine vapors. Again, all of the glassware has been cleaned and dried, and we're simply heating this mixture to around 35 to 40 degrees Celsius, and we're hoping to observe generation of the iodine vapor. Once we've seen that, we'll add some additional solvent, and then from there we'll begin to slowly add our alkyl halide, which in this case, our alkyl halide is 2-bromopentane in order to generate the resulting Grignard reagent derivative of 2-bromopentane. So we'll resume once we start to observe the characteristic purple iodine vapors. Okay, so we observe the characteristic generation of the iodine vapor at around 40 degrees Celsius. You'll see an additional reference video with a close-up shot that we did of this reaction where you can actually see the iodine vapor. So now that we have prepped our magnesium and iodine, we are now going to add an additional aliquot of ether. Now this is still a heterogeneous solution, but we're going to add a little bit of an additional ether, and then we'll initiate this reaction and initiate Grignard formation by adding a pre-prepared solution of 2-bromopentane in ether. You have to add it very slowly because the initiation is exothermic and we don't want this reaction to run away from us. Okay. So during this time, we're going to just let the ambient heat of the heating block maintain the temperature. We don't want it getting too hot because then we'll end up with an uncontrolled reflux, and that would lead to a poor reaction outcome. So we're going to inject an additional 100 microliters of ether. Okay, perfect. So we've added an additional portion of ether into our reaction mixture. And now what we're going to do is we're going to carefully add our 2-bromopentane solution. We're going to carefully add our 2-bromopentane solution. And for our first initiation, we're going to add roughly 6 to 8 drops. And let's just zoom in so that way we can get a good view of the drop-wise addition. And you'll see this characteristic formation of bubbles on the magnesium surface. So first we're going to draw our 2-bromopentane solution into our syringe. And now we're going to very carefully add roughly 6 to 8 drops. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now we're going to very carefully observe our magnesium, and you'll see in our reference video that bubbles are beginning to form on the surface of our magnesium pieces. And so now what we're going to do is we're going to carefully add the remaining volume of our 2-bromopentane solution dropwise over an extended period of time. Note we want to have this mixture gently heating at roughly 35 to 40 degrees Celsius. So we're going to continue on with our dropwise addition. And we're going to add this drop-wise over about 3 to 5 minutes. So considering that we have roughly 200 microliters remaining, we're just going to add roughly 40 microliters per minute. So we're going to add it in a slow drop-wise addition. It's important that the addition is slow, so that way you don't end up with a runaway exotherm. Okay, so we've completed our addition. Now what we're going to do is we're going to take our vial that contained our bromopentane. We're going to add an additional 100 microliters of ether and then add that remaining aliquot. So we finished our first addition. Let's rinse out our vial containing 2-bromopentane and then add that as the second portion. So we're now adding our rinse vial as one portion, and that just ensures all of our 2-bromopentane has been successfully transferred into our reaction vial. And we add this as one portion. So we've completed the addition of our rinse vial portion. And now what we are going to do is we are going to allow our reaction mixture to continue to heat gently for about 15 minutes, retaining the temperature at about 40 degrees Celsius. So as you note in our setup, our heating block temperature and our reaction vessel temperature is approximately 40 degrees Celsius. We've added all of our 2-bromopentane reagent, and we should see by the end of this reaction a pretty interesting color change in our reaction mixture from the characteristic sort of purple color of the iodine magnesium mixture to more of a gray color of our final form Grignard reagent. Of course, the true evidence that we've successfully generated our Grignard reagent will be during our back titration procedure, where we will neutralize the Grignard reagent and then determine the amount of Grignard reagent generated via back titration. So we'll resume at the end of the 15-minute heating period. Okay, so we have completed our heating step and we've generated our Grignard reagent. So now what we're going to do is we're going to raise our vial off the heating plate. Okay, and we're going to allow our reaction mixture to cool to room temperature. One thing that I would like you to note is if we look at the color of our Grignard solution, we notice that our overall reaction mixture has changed from the characteristic purple color of the iodine in our iodine reaction mixture, and now we have this relatively gray colored Grignard solution. For our next steps, after we allow this mixture to cool, we are going to neutralize this mixture with a defined quantity of 0.2 normal sulfuric acid, and then we are going to back titrate the remaining unreacted sulfuric acid, and from that back titration we can calculate the number of moles of Grignard reagent that we generated, and we can estimate the concentration of Grignard reagent in this solution. So we'll resume once this reaction mixture has cooled and we begin the neutralization step. Okay, so for our next step, we are going to quench our Grignard reagent and generate the magnesium hydroxide salt. So we're going to disassemble our apparatus. And now what we're going to do is we're going to carefully transfer our Grignard reagent solution using a syringe into a 50 milliliter Erlenmeyer flask containing 10 milliliters of boiled water and a drop of phenolphthalein and a boiling chip. We also have an additional 0.5 milliliters of diethyl ether used for our rinse. So let's transfer our solution. So we've drawn our Grignard solution into our syringe, and now what we're going to do is we're going to transfer our Grignard solution, and we're going to carefully add it to our water solution, slowly. And as you notice, the resulting phenolphthalein indicator is changing color. And our solution is warming. The Grignard reagent is being quenched. Now we're going to rinse the remaining Grignard solution left in our reaction vial using a 0.5 milliliter aliquot of ether. So we're going to use this ether rinse. Now, one thing you do want to be careful of, and this is really important, you want to be careful that you don't draw any magnesium, as the magnesium will react with your sulfuric acid. And you really don't want to have that to happen, because then it'll give you an inaccurate titer. Okay, so you don't want to draw any pieces of magnesium. So we're going to draw up this rinse aliquot, and we will quench it using the exact same method. So we're transferring the remaining rinse portions, and we are quenching our Grignard. And we'll resume once we've completely transferred all of our Grignard solution. Okay, so now we've completely transferred all of our Grignard reagent and quenched it to generate the magnesium hydroxide salt in water. Now what we're going to do is we're going to add a defined portion of 0.2 normal sulfuric acid, roughly 5 milliliters. 0.2 normal, remember 0.2 normal sulfuric acid, since it has 2 proton equivalents, is equivalent to 0.1 molar sulfuric acid. Based on the amount of sulfuric acid added, that sulfuric acid will react with our magnesium hydroxide salt of our Grignard reagent. And from that, based on the amount of sulfuric acid reacted, we'll have a certain amount of sulfuric acid remaining unreacted. Then we will back titrate that sulfuric acid with sodium hydroxide, and based on the amount of sodium hydroxide needed to quench the excess sulfuric acid, we'll be able to figure out the amount of reacted sulfuric acid, and in turn figure out the amount of Grignard reagent that reacted with the sulfuric acid. Remember, the sulfuric acid is a diprotic acid, and that's important to consider for your calculations in this back titration. So we'll resume once we have added a defined aliquot of 0.2 normal sulfuric acid. And we have our barrette set up and ready to go for our titration. And we'll be taking initial and final volume readings for this back titration. So we'll resume once we add our sulfuric acid. Okay, so we're now ready to add roughly 5 milliliters of 0.2 normal sulfuric acid. So this was freshly titrated, and you're going to need to record the concentration found on the label. This is normal, not molar. So you'll need to divide this by 2 to get the molarity. Okay, so now what we're going to do is we're going to add roughly 5 milliliters of 0.2 normal sulfuric acid. So we have our graduated cylinder prepared. So let's zoom in on the graduated cylinder and let's record. Okay, so I would like you now to get a good view for that. So I'd like you now at eye level to record the volume of 0.2 normal sulfuric acid added. Okay, so now that we have that set up and ready to go, we're going to zoom out and we're going to add our 0.2 normal sulfuric acid into our magnesium hydroxide mixture. This will neutralize the magnesium hydroxide mixture generated from our Grignard, and then we're going to back titrate the sulfuric acid. As you notice, as is supposed to happen, the pink color associated with the phenolphthalein has completely disappeared. This is ideally what should occur. If the pink color does not disappear, we would need to add additional sulfuric acid. Now what we're going to do is we're going to transfer this mixture into a sand bath and heat it at about 90 degrees Celsius for 5 minutes. We'll resume once we've transferred this mixture to the sand bath. Okay, so we have our mixture sitting in the sand bath, and we'll allow it to sit in the sand bath at 90 degrees Celsius for about 5 minutes, and we'll resume once we've completed this heating process. So in the meantime, while our sample is heating, we're going to condition our barrette. So we have set up a micro barrette, and we're going to condition that barrette with our sodium hydroxide solution. Here is the concentration of our standardized sodium hydroxide solution. You'll need to note this to complete your calculations. So now what we're going to do is we're going to condition our barrette by drawing in a volume of our sodium hydroxide solution, and then we're going to expel that volume into the waste. We've conditioned it off camera multiple additional times. So now to prep our barrette, we're going to draw in Okay, and now to make sure that the tip of the barrette is air-free, we're then going to expel okay, perfect. Okay, so while we're waiting, we're now going to zoom in on the top of our barrette. Okay, now that we have a good view of our micro barrette, I'd like you to record the initial volume in the barrette. Okay, so we finished heating our mixture of sulfuric acid reacted with our magnesium hydroxide generated from our Grignard reagent. Now what we're going to do is we're going to utilize our micro barrette and we're going to slowly add sodium hydroxide into the mixture until we reach the end point. That will determine the amount of excess sulfuric acid that is remaining in this mixture. So we'll carefully add our sodium hydroxide dropwise. And we have to titrate this mixture while it's still slightly warm. It's important in terms of technique. Okay, we're not really seeing anything yet. As we're approaching the end of the barrette, and we may need to refill, we're going to record the final volume from our first addition. So from that, I'd like you to record the final volume from the first addition. We're not quite done, but we need to refill this micro barrette. Okay, so we're going to refill the micro barrette and reset to another initial volume. So, one moment, allow me to get the... Please record the second initial volume. We're still titrating the same mixture. We just need more sodium hydroxide than was found in our barrette. So now that we have our second initial volume, we'll continue on with our titration. Okay, as it appears we need even more sodium hydroxide. That's okay. We're just going to record our second final volume in the barrette. One moment. Okay, so from that, record your second final volume in the barrette. We're then going to refill the barrette and record another initial volume. Sometimes it's hard to tell based on the procedure when you're running this titration how much sulfuric acid to add. Based on the procedure, we added 5 milliliters. That's a fairly large amount of sulfuric acid for the back titration, but nonetheless, we can certainly accommodate. I'm going to refill this barrette just because I noticed an air bubble and didn't want that interfering with our data. So now I would like you to record the third initial volume after we refilled our barrette. We're still titrating the same sample. It just requires quite a large volume of sodium hydroxide. Okay, so we're now set to continue on with our titration. We're starting to see traces of the pink color appear. So we're going to go a little bit more slowly this time. Still nothing, but we're getting close. So we're going to record. We're going to add a little bit more. Okay, and now we're going to record before we refill our barrette once again. Okay, we're now going to refill the barrette once again. And now I'd like you to record the initial volume in the barrette again. You're going to need to add all of these volumes added together in order to get the total amount of sodium hydroxide added. So let's keep going with this titration. Okay, as you notice, if you look carefully at the flask, and if we zoom into the flask, we're starting to see more of this pink color begin to develop. So we're almost at the end point. The pink color is starting to persist. It's going to need one more aliquot set. So let's record the final volume once more, and let's refill. So let's record the initial volume in the barrette once again. And now let's continue with our titration. So the pink color is starting to persist. And as we notice now, our mixture has taken on this light pink hue. And that's a sign we slightly overshot the end point, but it's not too bad. So let's record our final volume. Okay, by adding up all the volumes of sodium hydroxide added, you can determine the amount of sodium hydroxide required to neutralize the sulfuric acid, and in turn, from that information, you can calculate and figure out the amount of excess sulfuric acid, and then from the amount of excess sulfuric acid, you can calculate using the initial amount of sulfuric acid added using our graduated cylinder, you can calculate how much sulfuric acid reacted with our Grignard reagent, and in turn, you can figure out the moles of Grignard reagent generated. So that's all the information you need to complete this laboratory. And so from this video, you'll be able to complete your laboratory report.